Hello students, today we are going to discuss the example based on the divergence and the curl. In the previous lecture, we have seen what is divergence and what is curl. So in this lecture we will see the example based on the divergence and curl. So if you want to recall what is divergence and curl, go to my previous video, watch it, then you solve this example, then it would be very easy for you. So we'll start with the first example, students. Now what is first example? Answer 1. First we'll solve example number A. So what is A? If f bar is equals to 2x square I minus 2yzj plus 3z square k. Fine. Now what we have to find? First we have to find the dot product, students. So what is dot product? Dot product gives us the divergence of f, and curl product gives us the curl of f, students. So now we'll find first to find divergence of f means del dot f bar. So how we'll find del dot f bar? So the formula of del dot f bar is del by del x I caret plus del by del y j caret plus del by del z k caret, and f we have given 2x square I minus 2yz j plus 3z square k, students. Okay, now this is our f1, this part is our f2, and this is our f3, students. Now we'll write I dot I become 1. ये हमने अगले लेक्चर में देखा था. Now we'll find the partial derivative of f1 with respect to x. So what is the formula? The formula was del f1 by del x plus del f2 by del y plus del f3 by del z, students. Okay, so this is our f1, this is our f2, this is our f3. Now we'll find the partial derivative of f1 with respect to x, f2 with respect to y, and f3 with respect to z. So we can write del by del x f1. f1 is 2x square. So we'll write 2x square plus del by del y. f2 is minus 2yz. Remember, students, we have to consider the sign. So it is minus 2yz, and plus f3. f3 is 3 del by del z, 3z square, students. So this is the way you can find the divergence of the function. Okay. Now with respect to x, so x square become 2x, so 2 2s are 4x. With respect to y, so it is minus 2z, and with respect to z, that is plus 6z. So you can write 4x plus 6z minus 2z, students. So it is plus 4z, students. Now 4x plus 4z, this is the divergence of the vector, students. So this is our answer. So we have seen the first example A, that is the divergence of the vector function. So answer is 4x plus 4z is our answer. Now we'll see the curl of this given function. So we'll find del cross f, students. I will find del cross f. We know that we have to take the determinant where you have to put the value, students. So now we'll find del cross f. So how can you find del cross f? To find del cross f. So del cross f gives us the curl of a vector. So how we'll find curl of a vector, students? This is equals to determinant I, j, k, f1, f2, sorry, मैंने गलती कर दी, del by del x, del by del y, and del by del z. Then we'll write f1, f2, f3. So we'll put the f1, f2, f3 here. So what you can write? I, j, k, and del by del x, del by del y, del by del z. f1 क्या है बच्चों? 2x square. So we'll write 2x square. f2 is minus 2yz, and f3 is 3z square. So this is our determinant. Now you know that how to simplify the determinant, students. So we'll write I as it is. Now we'll take the cross multiplication, but we'll find the partial derivative of this function with respect to y. I am doing directly cross multiplication. You have to take the partial derivative of this function with respect to y. If you take with respect to y, it gives you 0 because there is no y at all, students. Now minus minus plus sign. You have to take the partial derivative of this function with respect to z. With respect to z करेंगे, so z is 1. The remaining is 2y, students. Then minus j in the bracket. Forget the second column, first row, students. Now we'll simplify doing cross multiplication with respect to x. Del by del x, 3z square. It become 0 because there is no x, and with respect to z of this function, 2x square. Also there is no z, students, so this become 0. Then plus k in the bracket, again cross multiplication with respect to x. With respect to x, if you do it, there is no x, then this become 0. And here it is also with respect to y, but there is no y in this function, so this become 0. So it is 0, students. So you can write 0 plus 2y is 2yi, this is minus 0j plus k students. So we get 2 0 0 is the the curl of f students. So here we have found the vector. What we discuss is curl of a vector is always a vector. So we get 2 0 0 students. So this is the first example that we have seen, students. Okay. Now we'll see the second example, B part. Okay. Now we'll find B. What is B? Here we have given the f. At the point 1 0 2, you have to find del dot f and del cross f student. So here we'll write B is f bar is equals to x square yi minus 2 xzj plus 2yk. So first we'll find del dot f is equals to del f1 by del x plus del f2 by del y plus del f3 by del z, which is equals to del by del x. F1 is x square y, so it is x square y plus del by del y. F2 is minus 2xz, students, minus 2xz plus del by del z, it is 2y. So it is 2y and bracket over. Now with respect to x, so you can write 2xy. With respect to y, there is no y, so it is 0. And with respect to z, there is no z. Again, the derivative of this function with respect to z is 0. So finally you get 2xy. But we have to find this value at the point 1 0 2, students. So we'll write now del dot f at the point 1 0 2 is equals to, we have 2, x is 1, so we'll put 1, x is 1, y is 0, so here we'll put 0, so 2 into 1 into 0 will get 0, students. So this is our answer of this function, and we have found the divergence of the function, students. Now we'll find the curl of the given function, which is very similar to the first one. So now we'll find the curl of the given function. So how we'll find curl? That is del cross f bar, which is equals to I j k, and you can write del by del x, del by del y, and del by del z. F1 is x square y minus 2 xz, and here it is 2y. So you can easily simplify it. So first Take the cross multiplication with respect to y. So it gives us 2. With respect to z, z is 1, but minus minus become plus. So it is 2xi, then minus j in the bracket. With respect to y, there is no y. With respect to x, so it is 0. Here with respect to z, but there is no z, so again this gives us 0 plus k. Again cross multiplication with respect to x, x is 1, so it is minus 2z, and with respect to y, y is 1, so remaining is minus x square, students. So you can write 2x plus 2i, this is 0, and minus k x square plus 2z. Here we have taken minus common, students. So now we have to find del cross f at the point. Which point? 1, 0, 2. So here we'll write 1, 0, 2. So instead of x, we'll put 1, y0, z2. So it is 2 into 1 plus 2i minus k in the bracket. X is 1, z is 2. So 1, 2 2s are 4. 4 plus 1 is 5. So here we'll write 5. So final answer would be 4i minus 5k. So this we have found the curl of the given function, students. I hope that this is very easy. Just you have to simplify the determinant, find the derivative, partial derivative with respect to x, y and z, and you will get the answer, students. Very fine. Now we'll move to the second example. Okay. This is very important. We have to show this function, students, is both solenoidal and irrotational, students. Solenoidal, irrotational. So let us recall the things. What is solenoidal? सोलेनोइडल मीन्स जो डाइवर्जेंस की जो वैल्यू है वो 0 है. इट मीन्स डेल डॉट एफ इज इक्वल्स टू 0. अगर 0 मिल रहा है देन वी कैन से दैट दिस वेक्टर इज सोलेनोइडल, स्टूडेंट्स. एंड irrotational, when we can say that the vector is irrotational, जब कर्ल की वैल्यू 0 है, so del cross f is equals to 0. So we'll prove that this function is solenoidal as well as irrotational. So first we'll prove del dot f is equals to 0, then we'll prove del cross f is equals to 0, students. Okay, we'll start example number 2. Here f is, what is f? Y square minus z square plus 3yz minus 2x I plus 3xz plus 2xy j caret plus 3xy minus 2xz plus 2zk. Now what we have to prove? To prove, क्या prove करेंगे बच्चों? F is solenoidal. So how will prove solenoidal? To prove F is solenoidal. For that, what we have to prove? For that, we have to prove del dot F is equals to 0. So del dot F is equals to 0. So we'll write del means del by del x I, or you can write directly del F1 by del x, del F2 by del y, del F3 by del z, which is equals to del by del x. Okay, what is F1? This is F1. So I am directly finding the partial derivative of this function with respect to x. Okay, so this becomes 0. This becomes 0. There is no x. This term is also 0. And x is 1. 1 into minus 2 is... Sorry. So 1 into minus 2 is minus 2i. So this is minus 2. So this is minus 2. Now this function with respect to y, students. Okay. So this is 0. Y is 1. Remaining is 2x. So here we'll write remaining is plus 2x. And here you can see that with respect to z. So this becomes 0. With respect to z. With respect to z is minus 2x, students. And again with respect to z. Z is 1. 1 into 2 is 2. So here you can see that minus 2 plus 2 is cancelled. And 2x minus 2x is cancelled. So here we get 0. So hence we prove that the given function is solenoidal, students. Why? Because del dot F is equals to 0, that we have proved. Okay. Now, in homework, you have to find this vector is irrotational. So what you have to prove? Just simply del cross F. You find del cross F. If you get the del cross F is equals to 0, it means you can say that the given vector is irrotational, students. So please solve it like this. You will get your answer. Now we'll see the third example, which is very most important. So how we'll find the example number 3. Okay. Here we have given that this a bar is ax square y plus yzi xy square minus xz square j plus 2xyz minus 2x square y square k is solenoidal. We have already given this vector is solenoidal, means del dot f is equals to 0. हमको पहले से पता है. Then what you have to find? You have to find the value of a. You have to find the value of a. So how we'll find it? Let us see here. Here, given that you have to prove it first. So first you have to prove the given vector is solenoidal. So here, to prove, what to prove? Del dot A is equals to 0. So how will prove? Del F1 by del x, del F2 by del y, del F3 by del z. So what is F1? This is our F1, this is our F2, and this is our F3. So I am finding it directly. So with respect to x, so x square is 2x. So 2a 2xy, 2axy, yz, there is no x, so this term become 0. Then plus here with respect to y, so y square is 2y, so it is 2xy, minus with respect to y, there is no y, so this bracket is over. Now here with respect to z, z is 1, so remaining is 2xy, so we'll write 2xy, and there is no z, means this become 0. So here this is the 2axy, 2xy plus 2xy is 4xy, students. So here we have to prove that this vector is solenoidal. Somewhere we have made a mistake. Let us see. To prove del dot A is equals to 0 with respect to y, ax square y. Okay, this is not, this we have given, this is already solenoidal, so no need to prove this is solenoidal, this is already solenoidal, right? So here, given that del dot A is equals to 0, so this is equals to 0, so this is equals to 0, this is equals to 0. Students, ये हमको दिया गया है कि A है वो solenoidal है, so we have to find the value of A. Solenoidal है means del dot A is 0, so this is equals to 0, this is equals to 0. Now what we'll do, we'll take xy common, remaining is 2a plus 4 is equals to 0. If xy goes on this side, the remaining is 2a plus 4 is equals to 0. Therefore, you can write 2a is equals to, plus 4 goes on this side, then 2a is equals to minus 4. Therefore, a is equals to minus 4 by 2. So minus 4 by 2, therefore a is equals to minus 2, students. So here we have solved the 3 examples, students. In this example, we have given that this is solenoidal. If it is solenoidal, del dot A is equals to 0. Then we have to find the value of A. So here we have found the value of A, and A is equals to minus 2, students. I hope that these 3 examples would be clear to everyone. Now, in next lecture, we'll see some more example of the solenoidal and the irrotational term. Then we'll move to the next topic of the vector calculus, students. So I hope that this idea would be very clear into your mind. You just go and refer the example. This would be very easy for you. I hope that you enjoy my lecture, students. Thank you very much.